So this question asks us to use the method of sections to find the forces in members AC, BC, CD, and CE, and then indicate if they're tensile or compressive forces. So we're going to want to find forces in these members: AC, BC, CD, and CE. So we're going to make our first cut. It's going to be the method of section, so we're going to want to cut it. We're going to make our first cut straight through BD, CD, and then CE. And this will be helpful because it's cutting through the forces that we want to find, so it's going to be a lot easier to find forces with doing the least amount of calculations. So we're going to want to draw our free body diagram for our first cut. So it starts at A, and then here's B. So they are 5 feet apart here, 5 feet, and goes down to C, and then this distance here, this other part of the triangle, is 5 feet as well. And then we're going to have different forces acting on it. We're going to have force BD acting right here, and force CD acting straight across, and then another angled downward force, force CE, right here as well. So we're going to want to start by, we also have this 800 pounds downward force. So it's important to note that we have a triangle here. We're going to want to find our angles in here. So it's 5 feet and 5 feet. It's a 45-degree triangle. So the theta angle in this triangle, theta is equal to 45 degrees. We know that 5 feet and 5 feet, if you solve it out, it is 45 degrees. So we're going to want to write our equilibrium equations. So we have net forces in the x direction are going to be equal to 0, and our forces in the x direction are going to be force CD plus, and this is going to be, so this is like a little triangle here as well, and this is the same theta, so it's going to be force CE, but it's going to be times the cosine of 45, because we want the x component of the x component of this vector, and we're also going to have force, the x component of force F, or force BD, which is force BD times cosine of 45. So this is our equilibrium equation for forces in the x direction. We can take the equilibrium equation for forces in the y direction, which equals 0, and that's going to be negative 800, because we have this 800 pounds acting downward, minus, and it's the same thing, it's going to be the y component this time of CE, which is sine of 45, minus the y component of force BD, which is also sine 45. So these are our two equilibrium equations to start, but we can't solve for these yet. We don't have anything we can solve for. So we're going to also want to take the moment at C. And C is right here, and any forces acting through C we don't take in the moment, so it's going to make it a lot easier to solve for these. So we have this 800 pound downward force. It's going to create a counterclockwise rotation, and it's 5 feet from C. So 800 times 5. And then we have the x component of force BD, because the y component of force BD is going to be acting in towards C. So we're only going to take the x component of this. So that's going to be negative, because it's going to create a clockwise rotation. So force BD cosine 45, and that is 5 feet from C as well. And this is equal to 0. So now that we have these equations here, we can solve for force of BD. So when we do that, we find force BD is equal to 1,131.4 pounds, and it's positive, so it's tension. This isn't one of the ones that we need to solve for yet, but it's what we need to do to plug into these other two equations, and we can solve for CE and CD. So we have the force of BD, and we can plug it back in to both of our equations, and we end up getting, we have to plug it into the y equation first to get CE, the force CE, and this is one of the forces that we need. So force CE, it's one of the forces the question asked us to find. We end up getting is negative 2,262.7 pounds, and that's compression because it's negative. And then once we solve for force CE, we can plug both force CE and BD into the net forces in the x direction to get force CD is equal to 800 pounds. So we have 2 for the 4, solve for. And then the 800 pounds, also make sure we know that that is tension, because it is positive, so it's going to be a tensive force. So from here that we have all these forces solved for, we can just take the joint C and we can solve for the remaining forces there. So when we're drawing joint C, right here, joint C has upward force acting on it of force BC. We also have this force AC acting on it, and then we have force CD acting to the right, and lastly we have another angled down force CE. But we solve for both force CE and CD, so that makes things a lot easier when we're trying to solve for the force BC and forces AC. So we're gonna do our our equilibrium equations. So we're gonna do net forces in the x direction is equal to force CD minus, we're gonna do the x component of force AC, and so these angles here are both 45 degrees. Those are the same angles that they're the same angles that we used in the previous part of this problem. We still have these triangles. All these triangles in this system are the same. They're all 5 feet long, 5 feet wide. So they're just going to be the same triangle, so it's going to give us the same angles, 45 degrees. So we're going to take the x component of force AC, and that's going to be force AC cosine 45, and then so the x component of force CE is going to be positive, so positive force CE times cosine of 45, and this is equal to 0. So we can plug in the values that we found. So 800 is force CD minus force AC cosine 45. And then force CE is negative, so it's going to be minus 226, or 2,262.7 times cosine of 45. And this is all still equal to 0. So we can solve for force AC. We end up getting force AC is equal to negative 1,131.4 pounds. And that's the next to last force that we have to solve for. Now we just have to solve for force BC. And we can do that by writing out our net forces in the y direction equal to 0. And that's going to be positive force BC plus force AC in the y direction, the y component, and that's going to be times the sine of 45. Force AC times sine of 45 is the y component of that, minus force CE times sine of 45. So then we're going to plug in our numbers again. Once we plug in our numbers, we end up getting force BC is equal to negative 800 pounds. And this is a compressive force because it's negative, so remember to write out if it's compressive or tensive. And so here, same thing. This is going to be compression as well because it's negative. And so there we solve for the 4 forces we need: force CE, force CD, force AC, and then force BC. And that's what the problem is asking us to do.